Hello everyone, my name is Alexander Pierce and this is my video for Lab 1 about the physics behind charge tape. Let's first begin with the purpose. The purpose is to prepare two pieces of charge tape and observe their interactions based off their electrical charges. We will then determine approximately how much excess charge is on a piece of charge clear tape. We will achieve these goals using two models, an experimental model and a computational model. The experimental model allows us to observe the interaction between the two pieces of charge tape, and the computational model will represent this interaction and also perform calculations to determine the charge on each piece of tape. As for assumptions, we have that air resistance acting on the tape is negligible, the long tape can be treated as a point charge, each U-tape created has the same charge, and that tape is neutral until ripped from the base tape. And then these assumptions allow us to approximate an answer by reducing the calculations to a much simpler scenario. So here we just have a few important fundamental principles that will apply for our experiment. The first is Coulomb's law, or electrical force, and you can see that equation written on the screen. And essentially what we will conclude from this is that like charges will repel each other while opposite charges will attract. And then for gravitational force, we have to account for this because gravity is also acting on the tape. And then for Newton's second law, we can conclude based off this equation that F net is equal to 0 when the momentum does not change. This will prove to be important when we're analyzing the net force on the tape. And then we also have another expression for F net, which is just that F net equals the gravitational force plus the electrical force. And then written down below, we have a few different main results that we concluded, which are that the two U-tapes are positively charged and repel each other. Then we also have written both the magnitude of the electrical force and the gravitational force, the magnitude of the charge on one piece of tape, and then the deficiency of electrons on one piece of tape. So for our experiment, we have that the system is the charged U-tapes and the surrounding is just everything else. And then we also have that the electrical charge on that tape in the beginning is 0. And then for our process, we have that two pieces of U-tape were created by quickly pulling a piece of tape off the base, which resulted in a charge on the U-tape. The U-tape was determined to have a positive charge because it was attracted to a negatively charged pin. Then tape B was hung by each end on two rulers, and when approached with tape A, tape B began to levitate due to the repulsion of positive charges on each tape. The distance between tape A and tape B was then measured. So here are some measurements that we got from the experiment, and we will use these in the computational model. So here's the glow script code I wrote, and I just inputted some of the experimental data from the last slide onto this code in the constant section, along with just a few other values. And I used some key equations discussed in the introduction section in my code. So here's the equation for gravitational force, which is written right here. Then I also used the principle that based off Newton's second law, since the momentum of tape B is not changing, is concluded that the net y component of the force on tape B is equal to 0. So the magnitude of the gravitational force is equal to the magnitude of the electrical force. So I put that in my code to solve for the electrical force. Then since that value is now known, we can solve for the charge by just manipulating that Coulomb's law expression to solve for Q based off the electrical force value. And then just down here, we solve for electron count, atom count, and then we solve for the ratio of deficient electrons to atoms. So here's the free body diagram that was outputted from my code, and as you can see, the lengths of each vector for the electrical force and gravitational force are equal because they have the same magnitude, and we have the values for these two listed right here. Then we also have the magnitude of the charge on tape B. We have the deficiency of electrons, which is just the number of electrons the tape lost when we charged it, and then we have the ratio of deficient electrons to atoms on that tape. As for comparisons between the two models, we have that the U-tape used in the true experiment had charge distributed throughout the tape, but the code only represented the charges on these tapes as point charges. We also have that the charges on these U-tapes were likely not identical, although they were assumed to be so in the computational model. Both models have a positive y direction electrical force and a negative y direction gravitational force acting on tape B. The computational model is also simulated for a perfect world. In actuality, there are other forces acting on the tape other than just electrical and gravitational, but this computational model did not account for it. As for potential sources of error, we have that the piece of tape could have had different charges from one another. Mishandling of the tape could have resulted in charge discrepancies. We did not account for other forces from the surroundings, like air resistance, and the tape mass was an estimate and not truly measured. To answer the what if question, it would be that the magnitude of charge on the tape would remain the same, but the sign would change, and then the direction of the electrical field produced by the tape would change. However, the tapes would still interact the same with one another and with other objects, and this is because like charges repel and opposite charges attract. And then for that why question, electrons can be transferred between any objects, including your hands, to the tape. And so transferring electrons to the tape would reduce the positive charge on the tape and potentially neutralize it, meaning the repulsion between charged tapes would not be observed. For our conclusions, like charges repel one another and opposites attract, objects can become charged through contact alone, since contact can result in transfer of electrons. Everyday objects follow and can be used for demonstration of fundamental physics principles, and Newton's law and Coulomb's law play an important role in understanding how an object will behave based on its surrounding forces, including electrical and gravitational. Thank you so much for watching.